All right, so in this section, we are going to be talking about quadratic functions and their properties. Now, once we're finished with this section, we're actually going to be using all of this information that we accumulate in this section to start building mathematical models using quadratics. And that's one that will very much be on the test. Okay, so make sure that as we're going through these that you ask questions and that you are ready in class to go over them. All right, so let's start off by defining what a quadratic function is. A quadratic function is a function in the form of a quadratic, right? So we've got f of x is equal to ax squared plus bx plus c, where a, b, and c are just some real number, and a is just not equal to 0. And that's just because we can't divide by 0. All right. So it's going to ask us to graph the function 2x squared plus 8x plus 5, and then find the vertex and the axis symmetry. Okay, so one thing about this, and I'll go over this here in just a second, but the vertex is either the peak or the belly of the quadratic. Okay, and then the axis symmetry is the line, the vertical line that goes through that peak or belly. All right, so to graph this, notice that this is not in the function notation that we talked about in the previous chapter, where it was a times x minus h squared plus k. Okay. However, we do want to be able to get it into this format. Okay. So the way we're going to do this is by completing the square. So I'm going to give this to you in steps, and notice that there is a lot of room in this, so you are going to have to space this out or you're going to be using all of this space. Okay, so complete the square. So we've got a little bit of math that we need to do first. All right. So when we complete the square, the first thing we need to do is to section this stuff off. So we've got f of x is equal to 2 times x squared plus 8x plus 5. I'm going to start off by separating my first two terms from the constant. Okay. Now, in order to complete the square, we have to have this first term with just an x. We can't have a coefficient in front of it. So what I'm going to do from here is I'm going to divide it out. Okay, so I'm going to simply divide the 2 out of both of these first two terms. So I'm going to have 2 times x squared plus 4x, and just so we can save on some space, I'm going to give myself just a little bit of room here and put a parentheses there. Okay, I'm going to give myself just enough so I can write something there. All right, so the next thing we're going to do is we're going to complete the square. So completing the square, so scratch. Okay, so completing a square requires us to do this. It's b over 2 times a squared. Okay, so we're pulling our b and our a from inside here. So b is going to be 4, a is going to be 1, and it should always be 1 because we've factored this 2 out. Okay, so it should always be 1. Okay, we're going to simplify this. This gives us, let's see, this would be 2 squared, which would be 4. Okay, so I'm going to add 4 to the inside, okay, and be really careful here, okay. I'm actually going to subtract 8 to the outside, okay. There's a reason I'm doing this. So I'm adding 4 to the inside because I've completed the square on the inside, but when I subtract it back out, I have to multiply it by whatever the outside number is. So I need to take these two numbers and multiply them. Okay, I'll make this not an x, it's times. Okay. All right, so let's go ahead and simplify this. Okay, so we have equals 2 times something, and we're going to go ahead and factor this here in just a second. So something squared minus 3. Now remember that there was a trick that we learned or we discovered whenever we were doing these in an earlier chapter. Remember that this is actually your factor. Okay, so when I write this, it can actually be x plus 2. Okay, if this were a minus, so it would be minus 2. but it's 2 times x plus 2 squared minus 3. Okay, now we can take this and we can graph this, right? So this is, if we're kind of identifying the parts, this would be left 2, up, down 3. And this is a stretch of a factor of 2. Okay, so I'm going to move my graph. We know it starts here. We're going to move our graph to the left 2 and down 3. So our point should end up right here. Okay, and then typically what you would see is a parabola doing this. Okay, so these would be the first 5 points. However, because it's a factor of 2, instead of being to the right 1 up 1, it's actually going to be to the right 1 up 2. Okay, so we have this. And then instead of being to the right 2 up 4, it's going to be to the right 2 up 8. Okay, so it would actually end up somewhere up in here. Okay, so we do have our parabola, right? So we have, and what I expect from you guys for right now until we start talking more in depth, which is going to come in later on in this section, this is about as good as I expect it to be. Okay, now let's go ahead and pick out the vertex and the axis of symmetry. So the first thing I would expect you to be able to do is pull the vertex. So the vertex is this point here. Okay, so I'm going to say the vertex is equal to, I'm just going to give myself the point, so it's going to be -2, -3. Okay, the axis of symmetry is that vertical line that goes through this. Okay, so it's a vertical imaginary line that goes through the vertex. Okay, once you've found your vertex, you can actually find the axis of symmetry. So axis of symmetry is just the vertical line, so x equals -2. Okay, that's all you got to do there. All right, so finding the vertex of an equation. Okay, so we're going to start with our function. All right, so we've got f of x is equal to ax squared plus bx plus c. Okay, so this is the function that we're talking about. Okay, you can find it. So your vertex is equal to h k. Usually we use h and k. I don't know what's going on. Usually we use h and k for our center point. So we're going to call our vertex our center. Okay, we can calculate h by this, so -b over 2a. We can calculate k by this, 4ac minus b squared all over 4a. Okay, so we can calculate our vertex directly from our function by using these two things. Okay, you can also complete the square more quickly. So we can actually say that f of x, if our function is a quadratic, we can actually turn this into into vertex form by simply doing this as a times x minus h squared plus k. Okay, so in order to do this, that's a horrible k. In order to do this, you are going to need to figure out what h and k are, but if you're not comfortable with completing the square, this is a fair bit quicker method. All right, so let's talk about some properties of quadratic functions. Okay, so first of all, the vertex v is equal to hk, so it's -b over 2a, and you can actually find k by just plugging that back into the function. Okay, so by evaluating at f of x, or f of h. Okay, axis of symmetry you can calculate by -b over 2a. It opens up if a is greater than 0. So if it's positive, it opens down if a is less than 0, if it's negative. Okay? So without graphing, we want to locate the vertex and axis symmetry of the parabola, and then determine whether it opens up or down. Okay, so we can actually do the up and down really quick. Okay, our A is -3. That is less than 0, so it is going to open down. Okay. Now let's do the vertex, or actually let's do the axis of symmetry. That's the next one we'll do. Axis of symmetry. So axis of symmetry you can find by simply saying x equals negative b over 2a. Well, we know b is 6, so negative 6 over 2 times a, which is -3. This would give us negative 6 over negative 6, which gives us 1. So our axis of symmetry is 1. Okay, so I'm going to go ahead and summarize that. Now the vertex takes a little bit more work. So our vertex, our axis symmetry and our h value is going to be the same. Okay, so we've already calculated 1/2 of it. Now to calculate this, we're going to have to find f of 1. Okay, so what that means is I'm going to plug in 1 into my function up here. Right, so I'm going to do that right over here. So f of 1 equals -3 times 1. So this would be k equals squared plus 6 times 1 plus 1. Calculating this, I'll leave that part up to you, but you should get 4 with me. Okay, so we can say that our vertex is equal to 1, 4. Right? So it takes a lot less calculation if you know what these equations are. All right, the next thing we need to kind of work through is talking about discriminants. Remember, discriminants are the part of the graph that tells us whether or not we're actually going to have real solutions, okay? And it comes from our quadratic equation. All right, so the quadratic equation says it's negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so the quadratic part, or the discriminant part, is the inside of the radical, right? Because if it's positive, we can have solutions, but if it's negative, we'll get imaginary numbers, and that's not something that we can actually graph, at least not on an xy plane. All right, so given a function f of x equals ax squared plus bx plus c, if the discriminant, so b squared minus 4ac, is greater than 0, so not negative, we have two separate x-intercepts. Okay, if the discriminant is less than 0, you have no x-intercepts, or no real x-intercepts. Okay, and then finally, if the discriminant is equal to 0, you have one x-intercept. Okay, so again, there are three cases. Either it can be greater than 0, less than 0, or equal to 0. And this is how we're going to determine whether we even need to look for x-intercepts. Okay, so we're going to use this. It says we want to graph the function using its properties, determine the domain and range, and determine whether where f is increasing or decreasing. Okay, so in graphing this, the first thing we need to do is figure out where the vertex is. Okay, so the first thing I would do is figure out where the vertex is in the axis of symmetry. Okay, so let's start with the axis of symmetry. So axis of symmetry is equal to, or is x equals negative b over 2a. Okay, our b is 6, so we've got negative 6 over 2 times a, which is -3. Okay, we've already done this together in the example before this, so we got a vertex or an axis symmetry of 1, and we can actually go ahead and calculate the vertex. So vertex is actually going to be 1, comma 4. Okay, so again, we're just pulling this from the example number 2. So I'm going to go ahead and plot this on our graph. Okay, so 1, 4 would be right here. That's our vertex. All right, so now we need to figure out, does this open up or down? So again, we can kind of look back over here. It said it was opened down. Okay, so we know it's opening down. Then let's go ahead and see if we even need to worry about finding the x-intercepts, right? So the way we do that is by determining the discriminants. Right, so finding the discriminants here. This is it's b squared minus 4ac. Okay, my b is 6, so I've got 36 minus 4 times a, which is negative 3, times c, which is 1. So we've got 36 plus, that would be 12. So you have a discriminant of 48. Okay, so because we have a discriminant of 48, we do have 2 intercepts, so we are going to have to find those. All right. So, hold on, guys. So we can find these, right? So our x-intercepts are going to be x equals negative b, so negative b would be negative 6, plus or minus the square root of, we've already found the discriminant, so we can actually just plug that in there, all over 2a, so this would be negative 6. Okay, and I'm just going to let you guys type this part into the calculator, and you can, and we'll move on from here. So we have, I'm going to do this with you, so negative 6 plus the square root of 48 divided by negative 6, and then, so it's either going to be negative 0.15, okay, so really close to 0, or, so negative 6 minus the square root of 48 divided by negative 6, or 2.15. Okay, so it's somewhere in here. So if I were to graph this on our points, negative 0.15 is right there, and 2.15 would be somewhere in here, and then our y-intercept would be somewhere in that region. Okay, so we have our graph. All right. So the last thing it's asking for is the domain and range in where it's increasing or decreasing. Okay, so our domain, remember we're looking at arrows, so it's going to be pointing to the right and to the left, the left and to the right, and we have no gaps in between them. So our domain is from negative infinity to infinity. Okay, our range, okay, it's how far down, up and down it goes. So we have arrows at the bottom, so we can point down, and we have a stopping point right up here, and it actually does go through 4, so we can include it. So we have our range. So our range is going to go from negative infinity to 4, and we're going to include it. Okay, it is increasing. Okay, so it is increasing from negative infinity to x equals 1. So remember, increasing and decreasing use x values. Okay, so it's increasing from negative infinity all the way up to x equals 1. And then it is decreasing from x equals 1 all the way up to positive infinity. Again, using our x values, not our y values. And there we have it. All right. So we would set this next one up exactly the same. So I'm actually going to skip this one, save it for those of you who come into class, and we'll work on this together. Okay. Yeah, so we're going to do these next two in class together. If you need additional help, that's fine. All right. Now, example number 6, this is the last one. It says determine the quadratic whose function is, determine the quadratic function whose vertex is 1, -5, and whose y-intercept is -3. Okay, so what I'm going to do first is I'm actually going to graph it. So 1, -5 would be right down here, and then it's got a y-intercept of -3. Okay, so by looking at this, there's not a whole lot we can tell. It's either going to be opened up or down. Okay, so what we need to do is we need to start calculating and figure out how this is going to look. Okay, so when calculating these, the first thing I'm going to do is I'm going to start with our basic function notation, right? So we've got f of x equals a times, we want this in vertex form, so x minus h squared plus k. Now, because this is our vertex, we know that this is our h and our k. Okay, so we can plug those in, right? So we can say that f of x equals a times x minus h, which is 1 squared, plus -5, so it'd be -5. All right, so now we have this. Okay, so we need to figure out what a is at this point. Everything else, we have an f and we have an x, so we need to get rid of that a value. Okay, so the way we do that is by using the other point that we were given. Now, it doesn't look like we were given another point, but we were. So this is a y-intercept. Okay, so if we were to write this as a coordinate, a y-intercept is where x equal to 0. So we've got 0, -3. Okay, so I can simply plug this in. So we've got x and we've got f of x. Okay, so we say -3 is equal to a times, we know x is 0 minus 1 squared minus 5. Okay, compute, we have this, and then add 5 to both sides, we get a is equal to 2. All right, so we can find the equation by replugging back in 2. And there we have it. Okay, so I just want to go ahead and finish off graphing this. Okay, so it is just it's a parabola that opens up, okay, because it's positive. It's a shift to the right 1 and down 5. And then we have these other points. And there we have it. All right, and that's it. Again, we're going to cover example number, we're going to save examples number 4 and 5 for in class. If you are one of those people who are out of class and need the extra help, feel free to reach out.